So I was thinking of sculpting each muscle using hollowed out electrical wire tubing like this, where the copper wire is pulled out and it's just the tubing. I felt like this would make for good muscle. It'd be kind of soft, but it'd give a little resistance and it'd hold its form nicely. So however you had it bent to form a muscle, pretend that was the top of the bicep. Pretend that this is the bicep muscle. As the arm pulls in, the bicep muscle would grow. As it extends, the bicep muscle would relax. So the contracting and relaxing of the muscle with this type of cord would look pretty natural. That looks like a muscle being made. If you picture, the arm being here. So let's say the pen is the forearm. That's like a muscle being made. And over the top of this tubing, I can put the silicone skin. Now, the flexible mesh exoskeleton I took from my body will give me a good guide as I make this tubing-based version of that. But I think just building the tubing-based version with this type of hollowed-out tubing, plastic tubing, will be easier than trying to cut out all of the insides of the grids of the flexible mesh exoskeleton I pulled from my body. That was going to be a huge job. So that exoskeleton isn't a waste. It still captured the exact dimensions of all the muscle mass of my arm and my face and my chest and my back. So that will be a guide I use to create my flexible tubing version of that mesh. So here would be how that would look. I feel like I want to keep the tubing as minimal as possible to lower weight and complexity of making it, but we'll see how that goes. So let's say here's the humerus. We would tie in the tubing the same way the bicep would be tied into the arm. So it would start here, and here would be the forearm bone. So it would actually tie into the forearm, and then it'd come to here, and then tie in somewhere in the shoulder. That'd be the bicep, and the tube could just be like 1, 2, 3, 3 of them. All right. And now as this bends in, these tubes will get shorter in length. And so, like, as the arm comes to here, right, these tubes, which are still attached here, are now shorter. So they're going to start to rise. So they'll actually be going up to their new location. And so it's going to look like the muscle's actually flexing. As the arm bends this way, these tubes will get shorter, and so they will get bigger, just like I showed you here. As the tube is longer, it gets flatter. As it gets shorter, it rises. And so that will enable me to simulate the flexing, the contracting and relaxing of muscles, the bulging of muscles under the skin. Now, I just showed the tubing running parallel with the bone, and I was thinking of making it a mesh, so there'd be tubing going side to side horizontal or perpendicular with the bone as well, like this. Like that. But that tubing would have to stretch to become longer, since the difference in length of a muscle relaxed like this, if you had tubing like that going around it, the circumference of that would be less than that same muscle contracted now the circumference of this is much bigger than the circumference of that. And so anything that were to connect them all in a perpendicular fashion for the muscle would need to be very flexible. And so I was thinking maybe for that I could use like spandex or even rubber bands. But then I was like, well, do I even need it at all? And the answer to that is possibly not. Possibly all the muscles could just be formed using parallel flexible tubing. And there won't be any horizontal lines at all connecting them. I'm not sure I'd need any, but I could be wrong. Or maybe only in some spots I'll need it, so I can experiment with rubber bands maybe, but rubber bands dry out, so I'd want to possibly stick with something like vinyl. Yeah, like I'd cut out maybe Band-Aid like strips from my vinyl surgical gloves. No, not vinyl, latex. I'm sorry, latex gloves. Right? Yeah. Yeah, latex. Yeah, my latex gloves. So I'd cut out little strips from the latex gloves, and then I'd put tape on the ends, and then I could wrap this around a tube. One of the parallel tubes, and then another one here. I could just wrap it around with the tape. And so that would enable me to span the two tubes. And then as the muscle contracted and this started to rise and separate, then this could stretch in either direction. So that would solve the perpendicular muscle fiber gap closers preventing the muscle from contracting and bulging. So that's the simple design I came up with for how the muscles can be shaped, or yeah, how I can simulate the flexing of muscles underneath the silicone skin of the robot. And it would all just be very passive based upon the movement of the bones causing the muscles to deform in the same way that the muscles of the body change shape as our bones move. But they're changing shape because they're actually being actuated. These are changing shape just through trying to pretend like they're muscles to give that illusion underneath the silicone skin. So it looks like there were muscles flexing. Okay, and then I was thinking that since we've got all of our motors strapped to the bone running the muscle wire, the actual wire that's going to actually be the muscles, running up and down the length distally along the bone. These wires can then be tied into the muscle, which I just told you how I'm going to make it using hollow tubing. I can like strap it onto the muscle in order to just kind of keep it out of the way of the motor area. The motor area needs to be kept clear of wiring and cordage and stuff like that the best I can in order to improve airflow through those areas, because it's going to be pretty tight quarters, and so keeping obstructions from blocking airflow is going to be important to maximize the cooling.